It's Don here from the board again. Thank you very much for joining in on another video. So we're going to continue in our series in regards to building a PCB using the Keyboard PCB guide by Ruki Mao. This is labeled part 2 of the series, but in fact it is actually the third video. So if you've joined in this playlist out of order, you can actually go back in our YouTube channel playlist and find the part 0 and part 1 beforehand. So let's keep going, and I'll switch over to the monitor, and here we go. So just for a bit of quick background, if you are still joining in late and you haven't actually watched the videos beforehand, we are using this guide which was created by Ruki Mao, and we are all the way down to the associating components and footprints. So in part 0 we did the setup, in the part 1 we did the schematics, and in the part 2, which is now, we're going to be doing components and footprints. Before we do that though, I do want to talk a little bit and correct on one of the things that happened in part 1. I had mentioned in part 1 that the Atmega controller that I was doing the schematic and lining up to wasn't the same as what was in the guide, and it turns out that I had actually inserted the wrong component. So when you load into KiCAD your component libraries, you do have to be careful what you load, because I'm just going to click over here and you'll see that there's a whole pile of different sources. What I didn't draw from was actually this keyboard parts of components, and that Atmega in here is the one that matches the guide. The Atmega that isn't in the keyboard parts sublist is the one that I initially started with, which would have been somewhere in this list elsewhere, in the 3,000 odd items that you can see loaded, and that was why it had slightly different pinouts. Now in that regard though, I actually don't know if the pinouts on the physical controller are going to be different, and I did talk about this briefly before, in that because this is a schematic, it might not matter at the end of the day, simply because of the fact that the pin locations for the controller are fixed regardless of the way that it's diagrammatically drawn. Now I have gone and changed over to the keyboard parts one, not in this video, but I just did it before, and I've fixed up so all the VCCs, the voltage lines and the ground lines, are all connected correctly, and I've restored all the other connections into the correct order as well. So that's how it looks. Now if we go and follow on with, let me just stop the pinging. There we go. Hopefully that'll take care of the pinging, the unintentional pinging. We go back to our guide. Let me just rearrange my tabs a little bit. Okay, there we go. We want to associate our components, our footprints, with the components that we've added into the schematic. So let's go to the CVPCB icon on the top as described here, and we're going to load in some of those components. Now the icon lives over here, that one there. Run CVPCB to associate components and footprints, and we're going to go with use the entire schematic, keep annotation, sort by, and close. Now did I do something strange there? Ooh, let's see. Okay, so it's because I've actually run KiCAD before, and it's not going to come up with that dialog, but let's see how we can get around this. So preferences, footprint libraries. Okay, let's cobble our way through. So there's preference, there's component libraries, and no, that's not right either. Ooh, you'll have to bear with me briefly. Click on the icon at the top. If this is the first time you need to add a footprint. Preferences, footprint libraries. Okay. Let's go back. Preferences, component libraries. Now, why is that not annotate? Is that going to give me? Okay, that's what we're after. It's just loading at the moment. Still loading. There we go. Alright. So that was on my other window. Here we go. And we're going to go Preference and Footprint Libraries. Now, you'll actually see here I've got the .pretties that I mentioned in part 0. You do have to make sure that it ends in the .pretties, because if you don't have that and it's got the TAC master on the end from when you unpack those zip files that you download from GitHub, then you may run into some problems. So you can use the Append with Wizard tool, and essentially you can find the particular files that you're after, those pretty folders, and it should add them in. Alright, now we have all these components that it has actually detected. So we've got 8 capacitors, we've got the 4 diodes, 1 for each switch, we've got the USB connector, we've got 4 key switches, we've got 4 resistors, a reset switch, the controller, and our ground device. And on every one of these, you can actually create an assignment of what the component is related to. We go back to our guide, we get down to here, this is what they're talking about, and what you want to pick up is going to be described in this block here. So we're going to say our resistors are the 8005 imperial size. The Atmega is going to be a TQFN package. We're going to use the hybrid through hole on husters for diodes, and that's going to be the 1U switch footprint. Crystal is the FA238 series crystal. The reset button will be a TL3442, and the USB will be a Hirose 5S8 connector. So let's see if we can find those components. Capacitors are 805. Let's go back to this. So if we select the capacitor, come down here, and we're going to look for capacitor. Capacitors. Now I'm not sure. I think is there a thing that will say, yeah, we go, keyboard parts. There we go. Keyboard parts, capacitor. Do we have a capacitor in the 805s? No. Capacitor. Alright. So let's go back up to our, as you can see, there is a lot of components in here. There we go. There's capacitors, SMDs, C805 hand soldering. Now obviously it's up to you if you want, the PCB to be set for machine soldered, factory soldered, or if you're going to build it with hand solder. So let's just go with hand soldered. And we're going to do that for every single one of them because it's the same. Now we're going to go find our diodes. There's our diodes. What did we say in the guide for the diodes? Oh, wrong window. It's going to be the handy from Hassu's library on our diodes. Okay, let's go back over here. So the diodes from Hassu's means it's going to come from one of those keyboard pretty or keyboard parts. There's the diodes. There's the 1, 2, 3 hands. Now I am kind of cheating because you can see what they've got listed here. So it's the keyboard parts D SOD 123 axial, which is the D SOD 123 axial. So let's go and throw all those diodes in. Then let's do a little bit of a quick. So that's going to be keyboard parts USB mini Hirose. So keyboard parts USB mini Hirose 5S8. Then the key switch. Now this key switch one, they've recommended the MX Alps 100. I was talking to somebody in the community about this the other day, and they said that if you're only going to be building a PCB specifically for MX, there is a nicer footprint which comes from Romar's GH60 build. Now you can look it up on the GitHub repository, and it does have the library components, and the fit apparently for the footprint is slightly nicer. Because this is a hybrid for MX and Alps, I believe something to do with the Alps means that the actual fitment of the switch is a little bit looser, according to this person that was talking to me. Now I don't want to name them, obviously, but that's just something to consider. There are different footprints, and if you want to get involved and learn a bit more, which unfortunately I don't have the knowledge about, you can create your own footprints as well. So resistors, SMD, the R805 hand soldering. Back to this again. Let's go resistors, universals, SMDs, and 805 hand solder. Now our switch is going to be, oops, what are we looking at? Buttons, switches, SMD, SW, SPT. Here my roll mouse. Rolling along. Did I go too far? I went too far. Is it under keyboard putts? Keyboard putts. Switch. Oh, let me have a look again. Obviously I'm not buttons and switches, SMDs, my bad. But at least you know, while watching me make these mistakes, where not to. Well, it's not really a mistake, but it's just really a time-saving aspect, I guess. Buttons and switches, there we go. And SMDs, SP, it's going to be one of these SP ones. And what did they say it was? It was the TL3342. So SPT TL3342. Now this is going to be the Atmega, which they've taken from Housings QFP 44 10x10 pitch 0. So let's have a look. Housings QFP 10x10 pitch 44 10x10. 44 10x10 pitch 0.8 pitch 0.8 0.8. There we go. And then finally we have the under crystals, crystal FA238 TX. Now I'm probably going to forget that again. Crystal FA238. So let's find crystals. FA. Now there's no FA here. I do remember actually from earlier that I had the same problem. Now let me just check somewhere else, because in case they've got it in here or not. But I was talking to my assistants, and they told me that for most part the crystal isn't going to be a big deal as long as you get that FA component correct. And there are a couple of different crystals out here that will kind of do the same job as long as that crystal model thing matches up. So I believe the Seiko has that FA. There's the 238s. And what other specific details that we're after? It's the TSX3225. So the TAX3225. There we go. So there's a TX8225, and we're going to go and use the hand solder. Yeah, this is the one that was recommended to me for some reason, as opposed to these ones particularly here. However, we'll just roll with it for the purposes of example. I don't know what's caused the deviation from the actual guide. I might not have the right libraries or something like that, or it's just something's been updated. But if you are going to be seriously building a PCB, you probably want to just double check to make sure that it's the right bits and pieces. Okay, so now all of those components are good. Let's close that and move on. So we have our components that kind of look like that, and let's generate our netlist. So using the netlist button, let's just save that footprint. We're going to close that and go back to our schematic, and there is the button up there for generate netlist. I'm going to say generate, and we'll save it in the same folder. We have our footprint, our net thing, sorry. Now we're going to go back and open the KiCAD PCB file. So back to our schematic, we're just going to close that for the moment. Let's save and exit. Back to base KiCAD, and you'll see over here there is the KiCAD PCB. We've also got the net and the schematic and the library. Now we open up the PCB, which looks like that. We are going to go and check our preferences for our footprint libraries. Preferences, footprint libraries manager, and we can see that our two libraries are still here, which is good. Don't have to add them again. We're going to set our grids. Now the grids basically allow you to align things to a certain degree. The larger the grid, the bigger the snaps. The smaller the grid, the finer the alignment. They've actually set a specific unit length here, which I believe is related to, say, the switch size, that footprint on the switch, which can help you line up your switches the way that you want. So 09375. Now I don't know if KiCAD's going to have any issues on that, because I've already been in this before, and oh, looks like I get to reset it. So 0.09375 and 0.09375 will set the grid. So you can see that lovely snap matrix that's happening there, which will allow you to set up all your components. Once we've set that up, we're going to go to read current netlist. So click on the netlist button and read current netlist. It's going to dump a whole bunch of stuff, and you're going to get this horrible thing. The first time I did it, I sort of flipped out because I was like, whoa, what's going on here? So we go to read netlist. We will say read current netlist. It says these are all the bits that we've gone in and pulled out. We're going to hit close, and there it is. Just to explain what's happening here is every component that we have that's in our netlist is stacked on top of each other. That's what it looks like if you just piled every single component on top of each other, which is what this is. And we're going to hide the rat's nest, and then we can start dragging things around. So over here, you can see the render tab, just over here, and you want to turn off rat's nest. And that's all the relationship connections that we've built in the schematic editor. Okay. Now, when I did this initially, it was a bit of a pain because it was all lumped up in the middle, and I had a much bigger footprint that I was building, and now I know a little bit better. So what I've just done is I'm just dragging and highlighting and saying I want everything, and then I'm just going to move it off to the side, and using the M key for move, you can see that it's going to ask which footprint do you want, all these capacitors, all these diodes, the USB, the pads, etc. And we're going to start just separating them out. So let's just grab all the components and put them somewhere. Now this can take a little while, depending on how big you've actually got to play with, what kind of components that you've got going on. And this is when it's very time consuming and there's a bit of patience required. So thankfully, at least for this build, it's relatively small. Now the 2x2 matrix means you've only got four switches to deal with. However, obviously the larger that you have a matrix, the more components you're going to have. your base electronics like the controller as well as your capacitors and all that kind of stuff is gonna remain fairly constant. I'm not going to say that it exactly is, but as far as I'm aware, the basis is going to be pretty similar. So these are the actual switch footprints that you can see now. Okay, let's drag that out. There's the key switch footprint there. We're going to have the resistors come out. Resistor 2, resistor 3, resistor 4. There's our reset switch, there's our controller, and then that's our ground. So that's all of our components. We're just going to separate them out just like that. So now let's get into putting it into a layout. They've actually separated them here just like I have, a little bit neater in a lot smaller space. And then what you want to do is you want to actually flip everything. Okay, you're going to flip everything but the switches. And what they kind of mean by that is you'll see the lettering here, the D1, the D2, the Amiga and all of that. That's actually backwards in reverse, because in the PCB editor it actually has front and back profiles. So if we zoom in right now, these are the correct way. But if I highlight this entire block and I say OK, and then I can move them around, I can right click and then I'll say I want to flip this block, and there you go. Now they're actually flipped and they're facing on the other side of the PCB. So what we want to do is actually flip all components except for the switches. Let's flip that. Flip all of those. Right. And then let's flip all of those. Now you'll notice that the switches, it'll say the column over here and the holes are facing the front, but the actual K1 is already on the back, and that is actually noticing the screen aspects of it, because this particular footprint has front and back components already built into that footprint. Now you'll see these are sort of slightly flipped around also, and if you really wanted to, you could play around with these and flip them so they're nice and neat too. Whoops. Let's rotate that around. I've gone and made a mess of it, haven't I? There we go. Can have a bit of a laugh at my expense, but at least you know if you do have any issues with that, you're not alone. Golly gosh, it's a little bit clunky, isn't it? So I don't want that, I want that. And let's rotate that around. Now we should probably get on actually, and while we're flipping and rotating this to match what they've got. So that's what they're going to put this arrangement. So the diodes are going to sit within the actual switch, but on the back. And it's very important because this is only going to work for SMDs. If you don't want SMDs and you want surface through holes, then you need to move this footprint so it's outside of the actual boundary box here, but within the line here. So it will sit like down here in this space. Okay, this actual white bit here is the keycap limit for a 1U, whereas these components are actually the switch housing limits. Okay, so just to make sure that that makes sense, this is only for SMDs because they're low enough profile that it's not going to get in the way. But if you do want through holes, and also because they're soldered to the surface of the PCB, not through holes, if you want through hole, you need to move them out of underneath the switch and into the gap space down here. So let's go back to the PCB bit here. There we go. And let's move our diodes. Now it's very important that you match them. So this is D1, which means it's going to go to K1. And I'm going to do what they've done, which is just plonk it within. If you don't want to have them in that position, obviously you don't have to, because you're going to build them for a different purpose. Okay, so there's your diodes done. Next thing, you're going to put the microcontroller right there next to it. So zoom out, zoom in. Oops. What is it doing? There's the microcontroller. It's going to sit about there. We can move bits as we need to. It's in the middle of the switches. That's just why is it doing this? There we go. It's roughly about there. It's pretty close. That's going to put the crystal down, and they're going to rotate it so that the actual pathways between, when you do the traces, are nice and short. Where's my crystal? There's the crystal. I'm going to move it over here. So let's move the whole lot just a little bit closer. Just a little bit closer. Alright, and you can actually do the right click and you can use the edit tool, which allows you a little bit more finer rotation. So you can go with an other rotation, and you want it to rotate minus 450, which will give you that. I think that's kind of the wrong way, so let's try that again, shall we? Other and 450, like that. Does that match what we're looking at? 1 3 3 2, 2 in the bottom corner. 1 2 3 4. Okay, I may have picked the wrong ground or something. I'm not entirely sure what's going on there. Pretty sure I picked the same one. Or maybe that's something that I've done wrong here with the crystal. Let's just go back up and check what I've got in the crystal. Yeah, so might be that because I picked that different crystal. Now, if you do actually have this problem, 1 2 3 4, and this crystal says 1 2 3 3. Alright, let's go back. So we can go back to KiCAD. We go back to our net. Well, let's go back to the schematic. We're going to go back to the actual relationship, CVPCB bit. It's going to do its thinking. And we go back to our crystals, and let's find another crystal. Let's check out the crystal choices. So it doesn't have the V on the end of it. Go back to here, and we got that one, hand soldering. So that might be the next best choice. Let's pick that one. Alright, and we'll save it. We'll close that. We're going to go back to our schematic again. We'll go back to the net. We'll generate it. We'll save over the top of that, which is fine. Save and exit. We're going to go back to the PCB. Going to go to the net tool. We're going to read that current net list. We're going to say yes. We're going to close that. And what have I done? What's next? After I read the net list, close. Okay, it did not change that. It's good learning experience, isn't it? While everybody watches me make these mistakes. Let's delete that. Let's try that again. Read the current net list. Yes. Close. Do I get magic components? There we go. Okay, so it's generated up here. Let's move that back down. Let's zoom in. and what do you know? It's still got the 1, 2, 3, 4. Alright, well, might not try and waste too much more time on this, so let's just keep going, and if somebody's watching this later on, they can help me figure out what's going on. So let's enter our parameters. We can go with other 450, which is in 0.1, so 45 degrees, and it will look something like that. Okay, we're now down to here. Let's place C1, C2 side by side to it. Let's drag our capacitors and our our resistors over here, so it's a little bit easier to get to, and also our switch and our USB. We'll just put over there, that way we're a little bit closer. So let's grab C1, grab the C2, I'm going to rotate them. Is there a particular orientation? You betcha. 1 on the bottom, 2 at the top. So let's rotate again. 1 on the bottom, 2 on the top, and then let's just move them 1 unit away with a gap in between. Alright. Next, we're going to move and put our 3, 4, 5, 6, and 7. Let's go move all of these a little bit off to the side. Move 3. Actually, 3 was on the bottom, wasn't it? 3, 4, 5, 6, 7. And then I'm going to make them so they're all, one side of them you'll see is 1 ups, and then on this side 1s are downs. So on this side 1s are up. Move that over there. Take that, move that over there. Over here it's going to 1 downs. And move that one down as well. Next, it's going to fit between 5 and 7 in the middle with 1 down as well. So let's rotate 1 down and move. There you go. So let's place our connector and reset switch. So there's the connector is going to be up the top, and then there's the switch underneath in the middle of the microprocessor. Let's move the USB. It's going to jut out a little bit. There's the switch. Okay. And the resistor we're going to place around so routing is easier. Now routing is really important. Routing is where I got stuck when I was building my own, and so I think doing the 2x2 is certainly going to be a lot easier compared to doing a much bigger matrix, which was what I attempted to create. So you'll see that we have resistor 1 down here, and then we've got resistor 4, 3, and 2 in the middle. So 1 up, 1 down, resistor 1, 1 up, move that down here. Resistor 2 is 1 down, move that there. Back to our guide. So 3 and 4 with 1 left, 1 left. 3, 1 left, 1 left. There's the... doesn't really want to snap very well, does it? No. Is it better there? And 4. Let's just check again how they've got theirs. So it seems like there's a gap that they've gone flush against that side, and it sits on the gap above there. So let's try. Oh, that's probably going to be the best that we're going to get it, isn't it? About there. Now, maybe, is that Gonna drag all of it. Alright, there we go. Just gives ourselves a little bit of gap space. Alright, and there is all of our components. Now, you'll notice actually that he's gone and said he's changed the grid size so you get finer movements. Yeah, it would have been nice if he'd actually mentioned that earlier, don't you think? So he's gone to that 234375. So how about we follow suit? We're going to go back up to dimensions, grid, and 0.02343775. Let's copy that into both. And what do you know? We can actually get some nice alignment happening, which makes it for a little bit nicer. Okay, excellent. Let's just save that progress so we don't go and make things any worse. We're going to do some edge cuts. So let's go to Layer tab, Edge Cuts to move the blue arrow, selecting the layer that we're working on, and then we're going to use the tools to actually draw some edge lines around everything. Go back over here. We have back to our layer, and we're going to go to Edge Cuts. So the blue arrow is there. Then we're going to use our tool to actually draw some edges. You'll notice that if I do the edge cut here, it's actually going to leave all those components out. So I'm going to shuffle all of these down. Are they going to fit? Are they going to fit? Maybe not. Let's move these a little bit closer, hey? And that way we got a bit of wiggle room. Move that entire block down just a little, and then the whole lot can come up about there. Alright, so the edge cut tool essentially just allows you to draw edges. It draws them in a yellow line, and essentially that's where the end of the PCB is going to be cut from when the tool is set in an actual reader. So I'm actually doing something like that. I've got, you'll notice, strange corners on those because I was going to try that arc tool, but I'm not sure if I can. Yeah, there we go. Let's try that arc tool. Just like that. Ooh. If I delete that, that's going to kill the whole line, isn't it? Yes, it is. Let's go from 1 unit away. Join that up. Let's get rid of that. I go from 1 unit away. I think the grid lines are a little bit messed up. Now, of course, I'm not very good at this, and hopefully when you come to do your own, you'll have a better experience in doing this. What on earth is it doing? There we go. Probably watching this going, this guy doesn't know what the hell he's doing. And you know what? You're kind of right. Oh, I just deleted that switch. So we don't want to do that. There we go. And I'll get my cursor on that. And we're going to delete that arc. Delete the line, not the switch. Alright, so we've gone and drawn that PCB edge cut. We're going to add a ground plane. It's just a big chunk of copper. So we're going to use that zone tool. Back on the FCU layer tab, select the zone tool, click on the corner of the edge cuts, and it'll tell you which you want it associated with. And so essentially what this is saying is on the PCB, how much copper are we going to lay in a layer that we can make connections to for the entire board. So we're going to go back up to that front copper layer section. We're going to go to that tool, we're going to click on that, and we're going to say I want that to be connected to ground. So now that's, I believe, ground planed. hopefully. And we're going to go and do that with alright, my mistake. We need to actually draw that space again. So let's zoom in. I'm going to say it's associated to ground, and we need to draw our borders. Okay, so we got the red crosshatch. We're going to go and repeat that with the BCU as well. So click on the edge of the zone, select zones, duplicate onto layer. Click on the zone. We don't have duplicate to layer. Let's see that again. Right click on the edge of the zone, zones, duplicate layer. Right click, zones, the edge of the layer. There we go, zones, duplicate onto layer, and we're going to select the BC2. Alright. Now we've got the red and the green crosshatch to match what is in the tutorial. Red and green crosshatch. So right click and select each zone, and for each zone, select zone, fill zone. Make sure the zones are filled. Select it on the left. That's the part there that they're talking about, show filled zones. So let's go the zones, zones, fill zones, zones. That's the layer that we want. Zones, fill zones. There you go, red and blue. And that means both the front and the back planes of copper are filled. Okay, and it looks just like that. Now we're going to go and hide those zones so that you don't see them. And that is going to be pretty much it for this. There we go. That's going to be it for this video. It's already clocking 42 minutes now. So I don't want to go any further because the next section, which is routing, is actually quite, well, challenging is a good way of describing it, I guess, for me at least. So I'll leave it here, and that way you can digest what had just happened, what took me 40 minutes to do, which might take you a little bit less because you've actually at least seen what's going on, and hopefully you won't make the same mistakes that I have. And then whenever I get up the next part, which is on routing, we can go through that. So make sure you save your work up here in the save section. And yeah, so on the next part, when we tackle routing, hopefully I'll be able to not completely Gumby it up in front of everybody, and you can see how entertaining routing can be. So thank you very much for coming along and checking out this video and watching all the other parts leading up to this. And of course, as usual, if you're new to the space and you haven't come across our podcast before, make sure you do check out our podcast, which can be found at www.theboardpodcast.com. So, until next time, happy clacking.